Hello all, welcome to my YouTube channel. Today we shall do Z-test for single proportion. Okay, let me read out the question first. It is claimed that 24% of the population are in favor of a new law. You collected a sample of 200%. It is observed that 45 are in favor of the new law. Okay, so we have to do hypothesis testing at 5% level of significance. So first part of the question is there enough evidence to reject the claim? That is, the claim is that P equal to 0.24. Is there enough evidence to reject the claim? And part 2 is that is there enough evidence to support that less than 24% of the population are in favor of the law? Okay, so we shall do the first part first and we shall do Z-test for proportion. Before that, let me tell you that we shall do the test in two methods. First is conventional method, where we shall find out the critical value based on the level of significance. Then we shall compare the critical value with the test statistic value and come to conclusion. And second part is done by p-value approach, where we shall find out the p-value and then we'll compare the p-value with the level of significance to come to the conclusion. Okay. Now let me tell you one more thing about hypothesis testing. Why we are doing hypothesis testing? See, it is a claim that 24% of the population are in favor of the new law, and our sample data is sample proportion 45 by 200, which is equal to 0.225. Okay. So that is 22.5%. So clearly from the sample we can see that this is slightly less than whatever is claimed. So can't we do direct conclusion? Can't we conclude that it is less than or it is not equal to the claim? No. Why not? Because this is a sample observation based on only 200 sample size, very less sample size. Population size is very large. So if we conclude about the population based on a sample, then we may be wrong. That is why we do hypothesis testing, to see that whether this data is supporting our claim. Okay, and we say that it is 5% level of significance. So whatever we conclude, that is not, we are not 100% sure. There is 5% chance that we may be wrong. Okay, so that is why we do hypothesis testing. So our hypothesis testing has various steps. So first step is formulating null and alternative hypothesis. So null hypothesis given by H naught is the hypothesis of no difference. That is, here we state that P is not different from 0.24. That is, population proportion is claimed to be 0.24, and from the sample observation whatever we find, that we claim that it is equal to 0.24. So null hypothesis is the hypothesis of no difference. Alternative hypothesis will be based on the question. First part is that, do the data provide enough evidence to reject the claim? So it is not told that whether sample proportion provides less than 24% or more than 24%. It is not mentioned in the question. So when it is not mentioned, we directly write that P is not equal to 0.24. Okay. So whenever alternative hypothesis has this not equal sign, then this is called two directional alternative hypothesis and the test is two-tailed. Okay. Then step 2 is finding out the value of the test statistic. Okay. For Z-test for single proportion, the formula is Z equal to P hat minus P divided by square root of P into 1 minus P divided by N. Okay. So P hat is the sample proportion, that is whatever value we get from the sample observation, that is 0.225. So putting the value here, P hat is equal to 0.225 minus P is the hypothetical proportion, okay, and divided by square root of P into 1 minus P divided by N is the sample size, that is 200. After calculation, we get the value as negative 0.50. I keep the value as up to 2 decimal places. Okay, generally test statistic values are kept up to 2 decimal places if not asked otherwise. Okay. Step 3 is the decision rule. Okay. So, given alpha equal to 0.05 and this is a two-tail test, okay, that means the critical value will be at the both tail of the standard normal curve, that is Z curve. Okay. So, for alpha equal to 0.05, the critical value of Z is ZC equal to plus minus 1.96. Okay, that means this side less than Z minus 1.96 and Z greater than 1.96, these two sides are critical region and middle part is the acceptance region. That means if the value of test statistic falls in the left side of negative 1.96 and in the right side of positive 1.96, then we reject the null hypothesis, otherwise we fail to reject H naught. Therefore, the decision rule will be reject H naught if Z modulus of Z greater than 1.96. Why we write modulus Z? We can write it like this: if Z less than negative 1.96 or Z greater than positive 1.96. In one formula we can just directly write it as modulus of Z greater than 1.96. Step 4 is the decision. Okay, our value of test statistic is Z equal to negative 0.50. Okay, we can clearly see that this negative 0.50 lies somewhere here. So, this is lying in the acceptance region. Okay. So, since the value of test statistic, we make it mod Z equal to 0.50 only. Okay, and this is less than 1.96. Therefore, we fail to reject the null hypothesis. Okay. So, this is our decision. Step 5 is the final step. Okay, since we fail to reject the null hypothesis, okay, null hypothesis mu equal to 0.24, we fail to reject the null hypothesis. So, we conclude that there is not sufficient evidence to reject the claim. Okay. So, this is the final step. Then we shall do the problem with p-value approach. Now we shall do the same part 1 of the problem with p-value approach. For p-value approach, step 1 and step 2 are same, that is we formulate null and alternative hypothesis, we calculate the value of test statistic. Then we go to the third step, that is calculation of p-value. Remember, this is a two-tail test. Therefore, p-value will be at the both tail of the Z curve. Okay. So, our test statistic value was Z equal to negative 0.50. Okay. And p-value will be at the both tail. So, p-value will be Z less than negative 0.50 and Z greater than positive 0.50. So, the p-value formula is written as p-value equal to probability modulus of Z greater than 0.50. Okay. So, we can break it as Z less than negative 0.50, that is area to the left side of calculated value of Z and area to the right side of calculated value of z. Okay. Now from z table or standard normal table, we find out the area probability z less than negative 0.50, which is same area as this right side area. So if we find out the left side area, this is same right side area. Okay. Okay. So here we find out the table, z table, standard normal table, and area to the left of z. Okay. So from this z, we find out the value of z to be equal to negative 0.5, that is 0.5, negative 0.5. Okay. And our after decimal we have 0.5 and then 0. 0 means from here we see that this is the first column, 0.00. Okay. So this gives us z equal to negative 0.50, and the intersecting cell is 0.30854. Okay. So this is the area to the left of z equal to negative 0.50. Okay. So we write down whatever we got the value, 0.3085 from the standard normal table, and the same area is for z greater than positive 50. Okay. So adding we get 0.6171. This is the p value. Okay. Next is comparing p value with the significance level to come to the decision. How we come to the conclusion with the p value method? Okay. So what we do, we compare p value with the level of significance. Here level of significance is alpha equal to 0.05 and p value is 0.6171. We can clearly see that p value is much greater than 0.05. Okay. Therefore, we fail to reject H0. Whether the test is left-tailed or right-tailed or two-tailed, we always see that whether p value is less than 0.05, then we reject the null hypothesis. If p value is greater than 0.05, we fail to reject. Okay. So this is valid for all type of tests, that is left-tailed, right-tailed or two-tailed. P-value approach will also give the same conclusion since we fail to reject it, so there is not sufficient evidence to reject the claim. So we are done with the first part of the problem. Okay. Now we shall go to the second part of the problem. So second part of the problem, the question is there whether the data provides enough evidence to support that less than 25% of the population are in favor of the law. Okay. So formulate the null hypothesis first, that is p equal to 0.24. Null hypothesis, the hypothesis of no difference, so it contains the equality sign. It may be equal sign or less, greater than equal to or less than equal to. Okay. And alternative hypothesis will be depending on the question, less than 24%. Okay. So since this term less than is mentioned, so we shall write p less than 0.24. Now since the alternative hypothesis is containing this less than sign, that is alternative hypothesis is left directional. Okay. So if the alternative hypothesis is left directional, this is left tail test or one tail test. Okay. So it is a left tailed test. We can have, if alternative hypothesis is less than sign, this is left tail test. If alternative hypothesis is greater than sign, then it is a right tail test. So these are one tail test. And whatever we have done in the part 1, that is two tail test, where the alternative hypothesis were two directional, it has not equal to sign. The value of the test statistic we have calculated earlier, this remains to be the same, negative 0.50. So step 3 is the decision rule, alpha equal to 0.05, and this is a left tail test. That means the critical region will be at the left tail of the Z curve. Okay, so for alpha equal to 0.05, the left tail critical value of Z is negative 1.645. Okay, if you don't know how to find out the value of critical value of Z, then please ask me in the comment. I can make one more video for that. Okay, so this is our critical region, that is less than negative 1.645. okay, and right side is the acceptance region. Therefore the decision rule will be reject H naught if Z less than negative 1.645. okay, now our step 4, we know that the calculated value of Z is negative 0.50. This is 0 and negative 0.50 will be somewhere here. Okay, therefore our decision is fail to reject H naught, since it is not in the left side of negative H naught. Okay, since Z is greater than negative 1.645, we fail to reject the null hypothesis. Then we come to the final step of the problem, that is conclusion. Since we fail to reject the null hypothesis that P equal to 0.24, we cannot support the alternative hypothesis, that is P less than 0.24. Okay, so we say that there is not sufficient evidence to conclude that less than 24% of the population are in favor of the law. Then we do the same problem with the help of p-value approach. Okay, so null and alternative hypothesis remain same, and test statistic is calculated to be Z equal to negative 0.50. Step 3 is the calculation of p-value. So p-value will be based on the calculated value of test statistic, that is negative 0.50, and this will be at the left tail of negative 0.50. Since this is a left tail test, p-value will be only at the left tail. Okay, so the formula for p-value is Z less than negative 0.50. Okay, so we have already got the value of Z less than negative 0.50 from the earlier problem, that is 0.3085. Okay, so calculated value of P is 0.3085. So this area is 0.3085 and this is the P value. Step 4 is the decision. In p-value approach, we see that whether p-value is less than alpha. If p-value is more than alpha, we fail to reject the null hypothesis. Since here p-value is 0.3085, which is more than 0.05, therefore we fail to reject the null hypothesis. Okay, then we go to conclusion. Since we have failed to reject the null hypothesis that p equal to 0.24, then we cannot support that the alternative hypothesis HA, that is P less than 0.24. Therefore, the conclusion is there is not sufficient evidence to conclude that P is less than 0.24, that is less than 24% of the population are in favor of the law. Okay, hope you understand both the approach of this hypothesis testing problem. Okay, and I think it is helpful to you. If you like my video, please like and subscribe and to get more such videos. Thank you so much for watching.